On with Tab, Mama Wiggles presents Improper Fractions, starring Captain Math. Hey everybody, it's Captain Math, and today we're going to talk about improper fractions. But before we do that, let's review proper fractions. All fractions have two parts, the numerator and the denominator. I don't care what fraction you have, they always have a numerator and a denominator. The numerator for all of our fractions is what part that is shaded. But every now and then, the math teachers may ask what fraction is unshaded. But for all fractions, we're going to concentrate on the shaded parts. And the denominator says how many equal parts that it is cut into that represents one whole. And last thing about proper fraction is that the numerator must be what to the denominator? That's right! The numerator, the value of the numerator must be smaller than the value of the denominator. If we have that and we know that a proper fraction that's shaded will always be less than one whole because the whole thing is not shaded. That's a proper fraction. Today we're going to do just the opposite, and it's called improper fraction. So if you know what a proper fraction is, improper fraction is opposite of the proper fraction, where the numerator, the value of the numerator is larger than the denominator, and it's more than one whole shaded. So let's look at an example of a improper fraction. And as you know, I always love to draw when I'm confused. And I encourage you to do the same thing. When you don't understand something, draw it out. And then you will see the big picture. The number at the top, the numerator, must be bigger than the number at the bottom, which is the denominator. So here's an example of an improper fraction. And what does it say? It says that I need 7 parts shaded and it's cut into 3 equal parts. So let's draw it out. Okay, I like rectangles. Is that cut into 3 equal parts? Yes. Let's see if we can shade in 7 of them. 1, 2, 3. Uh-oh. I don't have enough, do I? That means I gotta do what? I gotta draw another one. Now make sure it's not connected, because if it's connected, then it looks like it's one big thing. So now, do I have enough to shade in 7? 1, 2, 3, 4, 5, 6. Guess what? I gotta draw another set of thirds. I'm gonna put it up here. Now, do I have enough thirds to shade in 7 of them? Okay, let's see. And we're gonna shade in 7 of them because that's what the numerator says. I'm gonna shade in 7, but I'm gonna cut them into thirds. So let's count. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. Now, did I shade in 7/3? 7 of them are shaded? That's right. And according to our definition of improper fraction, we know that the numerator 7 is bigger than 3. So we know that that's an improper fraction. And we can look at the picture and see that more than one hole is shaded. So let's see how many holes we have shaded. So I'm going to use another color. So this whole thing is shaded. So this is 1. This hole is shaded. So we have more than one hole shaded. So how many holes do we have shaded in 7/3? Which is 2. So we got 2 holes that's shaded. And what fraction is left? 1/3. Wow. So guess what? See that 2 holes is shaded and 1/3 is left over. Or we could count up the thirds. So 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 is 6/3 are shaded red, plus the 1/3 that is shaded red, which is 7/3. Let's look at another example. But if you don't believe it, let's see if it satisfies the characteristics of an improper fraction. Is the numerator bigger than the denominator or greater than the denominator? Is 8 bigger than 5? Yes. All right, and let's look at the other one. Is it more than one hole shaded? Well, we haven't figured that out, but already we know that the numerator, 8, is bigger than the greater than the denominator, 5. So now, if we don't know if it's more than one hole shaded, what do we do? That's right. We draw the picture. 8 of them has to be shaded, but it's cut into fifths. So we gotta draw a picture that is cut into 5 equal parts. 1, 2, 3, 4. Now, can we shade an 8 of them? 1, 2, 3, 4, 5. Oh, we don't have enough, do we? So what do we have to do? We have to draw another picture. Make sure it's not separate, they're not together. And we're going to cut this into fifths because that's what the denominator says. So we got an object now cut into fifths. Now, can we shade in 8 of these down? Okay, let's pick another color. Pick pink. So let's count 5 fifths. 8 times. 1/5, 2/5, 3/5, 4/5, 5/5. Oh, we got the whole thing shaded. And what's the whole thing shaded? 5/5. So 5/5 is already shaded. That's the whole thing. And now we gotta count some more over here. 6/5, 7/5, 8/5. So we have how many shaded over here? 3/5. If we add these two together, it should equal what we started off with. So 5/5 plus 3/5 is 8/5. Now that we have the picture, let's see if it satisfies this definition. More than one hole shaded. Is it more than one hole shaded? Absolutely. There is more than one hole shaded. This whole thing is shaded. So we got one hole that's shaded, and we got 3/5 that's shaded over here. So it is more than one hole shaded. So we know the characteristics of an improper fraction. We know that the numerator must be larger than the denominator and is more than one whole shaded. And we use our picture to see that it's more than one whole shaded. Isn't improper fractions fun? And you know what? We learn something else in the future. That this is the same as 1/2 and 3/5, which is called a mixed fraction. Because it has two types of numbers. It's got a whole number, and it's got a proper fraction. But that's later on. We'll learn that in the next episode. So stay tuned. If you enjoyed today's episode of Improper Fractions and you really enjoyed, I'm going to give you a challenge problem for you to do. You need a pencil, paper, and maybe some crayons. Challenge time! I just wrote an improper fraction on my whiteboard. Is the value of the numerator bigger than the value of the denominator? Is 9 bigger than 4? Yes. So far, we know that it may be an improper fraction. So, the next thing we got to do is it more than one whole shaded? Well, what do you have to do? You have to draw 9/4. So, that's where you're going to be creative. You're going to draw a nice picture. You're going to draw 9/4, and you're going to see that 9/4 may be an improper fraction. If you enjoyed today's episode, which I hope you did, and I hope you learned a lot and had fun doing it, please share and subscribe to my buddy Fun with Tab, where learning can be meaningful and fun. See you next time on the next episode, which we're going to talk about mixed fractions. See you next time, and always keep learning. Learning is fun.